Hey everybody, this is Larry. This is me doing the virtual contest of the Biweekly Contest 160. Hit the like button, hit the subscribe button, join me on Discord. Yeah, let me know what you think about this contest, this video, everything in between. This is not going to be an explanation video. This is the live solve video, so definitely check that out. I'm just getting my notebook ready, and yeah, let's get started. But that's it. Yeah. Each video with each problem will have his own explanation video. But this is just a live footage of me trying to solve this contest. And yeah, let's go. Yes, go. Let's have to adjust the thing. Okay. Hexadecimal. What's a hexatrixmal? Oh, base 36. I kind of knew that, did I? A concatenation. Okay, so 169. 89. Okay. This is not hard, but annoying, I think. Okay, so we have just hex. Okay. What's it called? I feel like you can write this and it works, but maybe I'm wrong actually. It's been a while. I'm not going to do very fast on this one. I don't. There is like a thing, but okay, fine. Let's just it's just very annoying to write. That's all. That ASCII lowercase. Is it uppercase maybe? Is that a thing? I actually don't think I ever used this, but yeah. Almost clicked on base by accident. Okay, so that is expected. Okay, so hex would be yeah, just base 16. So while x is greater than 0, x mod 16 and x to the by 16, right? So current for C. Yeah, all that appends C, and then now it is in reverse order. Yeah, so then we want to reverse it, and then we want to return. I guess this is just so annoying. That's all. It's not even hard. I probably should complain less and do more. Yeah, maybe I went like 2 C 16 for C in range of, or for C in R, something like that, right? And then maybe we have a 2x base, and this is per character. So if x is greater less than 10, or actually equal to 10, we return string of x, so a single digit. Else we return string of x minus 10 b of this. I guess technically the base doesn't do anything because it's handled for us, so maybe that's useless. Okay, so then now we could check out real quick. 13 is 11. That's n times n. So it should be a9 and 5 10. Okay, and then we just have to what's it called? Hexa. I'm just gonna go hexa, and it's just 36. And maybe actually, maybe this is b, and then now we can just return this plus hexa of n times n of 36, something like that, right? Is it, oh no, I didn't call it hexa. Or I was initially calling it hexa, but then I change my mind. I think the thing here is also 0. So okay, 0 is not a test case. So just run it real quick just to make sure that it doesn't cause anything weird. Shouldn't be though. Let's give us a quick submit. Okay, good. Really annoying for a Yeezy, isn't it? 5 minutes, maybe 4 minutes. It's kind of slow, but I was trying to be a little bit careful and not to write too much duplicate code. Okay. Yeah, remember the version 1 of this from last contest where it was a trick question or something. But okay. Rate cost, define the cost to rate on that cell. You start cells at second 1. Odd even seconds. What's the define the cost? Is the cost in the seconds matter? So there's entry cost and rate cost. But the second itself doesn't matter. The second itself doesn't matter. I mean, otherwise it's not that bad. It's just okay. And you wait, and it's just, I mean, you just pay it twice, I think, for every cell except for the beginning and the end. So it's a very awkward way of phrasing it, I think. And then it just becomes DP, right? Because of the first search, I guess, but it doesn't mean BFS. Because the actual seconds don't matter, right? So it's just a 2 operation thing. Okay. So then dp of 0, 0 is equal to just end. Just the entry cost, which is always just going to be 1, and then yeah, then it's just dp ij fmin is equal to xy, right. So let me just that's the cost of leaving, so it's just ij plus rate cost of I plus 1j plus the cost of entry, which is I plus 1 square or something. No, plus I plus 1, so yeah, okay, something like that, right? Of course. Something like that, right? And then in theory, it is this but minus 1, or minus the last rate cost at the corner. So let's just see if it's relatively right. 5, 13, 21. I think that's relatively right because we double count, because we never do the corner one, right? Maybe I should have just typed it in the first time, but 3916 is right, so let's give it submit. Hopefully I didn't miss a constraint. Okay, because maybe I should have double checked the constraints, honestly, but it's fine. That one 5 minutes as well. Wow, I feel like I'm really slow today. I feel like I didn't, well, just in typing, like I understood the problem immediately and I still took 5 minutes to implement. All right, anyway, let's focus. Minimum time to reach destination directed graph. You have a directed graph. All right. Edges you restart I. Okay, so you can only use this from start I to. Okay, that's interesting, maybe. And there are there cycles? Is it a DAG? I don't see any indication of whether it is a DAG or not. In 1 unit of time, so you can move, but that is, you know, return the minimum number of time. I mean, the cycles doesn't make sense in that you would never go back to it. Well, no, you still wouldn't, but I think the start I is. Start I doesn't matter. I mean, it matters, but it doesn't matter really that much. Okay, it's just dice true. It's pretty straightforward, frankly. Right. And then we start at 0, so press up 0, right? Right, and then we have a keep, right? Push to the heap, we have the 0, we have, which is the time, and then the node, and that's it. Is that it? I think that's it. And then we have the time and then the node, right? Yeah. If node is equal to n minus 1, then we return t. We can probably terminate early anyway. Otherwise, we return -1 in the impossible case. And then, yeah, it's just for restart n in e sub node. And then the idea here is that, okay, so what is, it's just a different cost function, right? So if n is, or if t is greater than n, can we leave at? Okay, then we just continue, we skip. Otherwise, we have to do the heap thing. I always forget. Maybe I don't always forget, but okay. Otherwise, then now we want to push the cost, right? So cost or new time is equal to the How long does it take? It doesn't say, actually. Does it take 1 second to? Okay, so it does take 1 second, actually. Okay, I actually forgot. For some reason I thought there'll be a cost. So okay, so nt is equal to, so it's either the start, so +1 because we wait until the start time, or t +1, right? So that's it really. I was looking for the cost, and maybe in a general sense it doesn't matter, but well, in the general sense this would just be a dynamic thing, but it doesn't really matter. All right, then if best of 3 is greater than nt, then That's basically gonna nt heap push h nt v, and we are good, I think. 3 and 5 and -1. Okay, YOLO submit. Hopefully no silly mistakes. Okay, good. I mean, it's a standard-ish problem, but I still feel like I make a lot of silly mistakes at times. So I don't know. All right, another 5 minutes. I don't know. I'm a little bit slow these days. It seems like. All right, because I knew what I wanted to do. All right, you're given an integer array nums and an integer max c. A subarray is stable if the highest common factor of all its elements is greater than or equal to 2. The highest common factor of all its element is greater than or equal to 2. Okay, what's a common? Okay, that even divides all elements. Okay, I guess that's what I would have expected. Just want to make sure. Stability is defined as the length of the longest stable subarray. Okay, you may modify at most max c element to any integer. Okay, return the any integer is interesting. That means you just skip that number, but well, maybe return the minimum possible stability factor of the array after at most is the length of the longest stable subarray. Minimum possible. What does that mean? Okay, let's say 510, which has 2. Change nums 1 to 7. Oh, wait. Maybe I'm misunderstanding this. Hang on. No subarray greater than length 1. Has HCF of greater than 2. Oh, okay. So the minimum. Huh. Not sure I understand this still, but I think I have a feel for it. Okay, so which has a stability factor of 3. So then we just have to change one of them, right? In theory. Do we have to change all of them? I don't think so. It's just subarray, right? A subarray is called stable with the higher of the minimum possible. Okay, so the longest stable subarray. I missed this part a little bit, or maybe I didn't understand it when I first read it. Longest. Okay, so that means that we just have to. Well, yeah. So we have a longest stable subarray, and then what? I mean, the tricky thing is that they're not they're not disjoint subarrays, possibly, maybe, depending on how it's set up. So I think that is maybe the immediate thing, right? Okay, you have 2, 4, and 9, 6, but there could be a case where, I don't know, maybe you have 2, 2, 2, 2, 2, 2, 2, and then maybe you have like I don't know, 10, and then maybe you I don't know. I'm trying to think whether it makes sense. Like if you have, I don't know, something that is or maybe a better one is like 6, 6, 6, 6, 6, 6, 6, and then you have 10, and then the other one, or just even just 2, and then 3, right? So if you have something like this, then this is one long subarray, and this is also a long subarray. So, and they're not disjoint. I think that's a tricky problem. That is a tricky problem in general. That said, the max C thing, the change factor does make it like you can make this a prime number, and so then you could always disjoint it. Where's my water? Did I finish my water? I guess I finished my water. And here, I mean, it's just trying to figure out how to track this. and dealing with off by ones possibly. Can you do it iteratively? Is there constraints? No, constraint is too big. You have 10 to the 5th. So if you just do it one at a time, trying to break it apart. And also that's not even necessarily the right way. I was thinking about like iteratively dividing them in half, but maybe that's not the, I mean, that doesn't make sense, right? Because for max c is equal to 1, then you divide two things in half, which is fine. But then if you have max c is equal to 2, you don't divide one by half and do it again. You actually take this whole thing and then you divide it by two thirds rather, right? You cut it twice to 3 parts. Maybe that's a more precise way. All right, give me some candy. Yeah, I think this is a binary search problem now that I think about it, right? Because we search on how many things it can do. I mean, I think this is binary search actually. I don't know why I didn't think of that earlier. Yeah, because then it almost doesn't matter. Then now the overlapping case doesn't matter because in a sense that you have to cut it off anyway from binary search. Okay, so binary search. I think binary search is right, but I think it's still a little bit tricky about overlaps. Because you can imagine, okay, let's say we want our overlap to be, let's just shrink this a little bit. This is too big, too kind of unnecessary big. So something like this, and let's say we want to test for 3, right? We test for 3 or maybe 4. Well, let's just say yeah, let's just say 4, right? If we only keep track of these 4 and then we see a 3, we ended the streak of 4. And then we may be like, oh, that's good. But no. You still have to end this streak. So you have to cut it off here instead because of this 3, right? I was about to think about it over. I think binary search is the way to go, for sure. But we have to think about how to handle this. Which I'm not quite, I don't know immediately yet, obviously. Too much candy. We have an hour. And I don't know, I took a peek at the times, but it's just all cheaters anyway. So it doesn't really help me try to figure out how hard this problem is in terms of timing. What a useless leaderboard. How do we keep track of the sex? Okay, so maybe we can look at the primes. We only care about the primes, right? Maybe? It goes up to 10 to the 9, it's a little bit awkward though. That means that we can do surf. It's very awkward actually. I don't know why they made it that way. But okay, so let's say we do keep track of the prime, then we go, we have a 3. we have a 3, and then we want to say, so we get the prime things. Okay. It means that, and maybe we have to pre-process it, which is fine. Is it still binary search, or we just need to pre-process it? No, it's binary search, because then you want to do the cut, so you don't have to think about it. Okay, fine. So for each number, factor it, and then contain the streak. I think that's fine. We just have to pre-process it, and then we look at the math and then do it, right? And because we have at most 30 numbers, or 30, yeah, 30 numbers, then it doesn't matter. Do we only have to keep track of primes? Does it matter? No, yeah, we only have to keep track of primes because even if the overlap is 4, as long as it's overlaps of 9, 1, then it doesn't matter. So okay, so we don't have to care about the number of primes, so we just have to care about primes. 10 to the 9's wonky though. I think with using Ceph would have been pretty nice, but okay. Okay, so then how do I want to implement it? Okay, I mean, prime up to 10 to the 6. So do we still want to do Ceph? I think we still want to do Ceph. Is this fast enough? I don't know. I think the algorithm is relatively fast, but is it fast enough? Square root of x times 10 to the 5th is pretty not great, honestly. Can I be a little bit better? Especially since we're adding a binary search, it just seems like all the costs add up. Even though, yeah, I mean, after the pre-processing is fine, but the pre-processing is so expensive if you want to get all the factorizations of x, right? How do I binary search straight for it? What am I missing? So it could be have a big number, right? But it could have a big number. That's the problem. How many primes are there? I forget how many primes under I don't know, 100,000 there are. 78. Oh no, that's not it. How many primes are there? About 10,000 primes under 100,000. Maybe that's right, but that means that that's way too many for us to mess around with. maybe. Why 10 to the 9? Is it that much easier? I don't know. What is the trick with the 10 to the 9? That's what I'm trying to figure out. Because if max is equal to 0, then this should be 5. If max is equal to 1, then what happens? 4 should be good. Because you remove this 3, not the other 3. Right? Because then now it becomes 4. I mean, in theory, you could... Well, in this case, the answer, you would probably even cut to 3, but... So the overlapping thing is definitely a thing, unless I'm misunderstanding the problem. How much time did I spend? I spent like 8 minutes just thinking about this already. I mean, even if max here is 0 to 0, it's just that if you don't keep track correctly, and the answer here is 5 and not 4, right? And this could be any 2 primes really, so any 2 primes. The 10 to the 9 is really throwing me off. Is it a segment tree thing? Maybe it's a segment tree thing. Can I get the, whatchamacallit, HCF? What they call it? I guess so. I was thinking about whether I can get a segment tree query of, like, just get a segment HCF, and then from that, can I? What will you do with it? Let's say you have a segment tree that gives you, I think you can, but and now. No, because you don't want the HCF of the highest common factor of the segment, because in this case, this becomes 1. This becomes 1, but that's not the thing, right? It is actually 4 that is here. So if we only have this subset, the HCF is 1, but the stability is 4 due to this chunk. So, and then maybe more when you kind of extend it. I mean, do you do a sliding window? I don't even know how. Yeah, even given a segment tree, I don't know if that helps. Because you query for a segment. And then what? And log it in square. And that may not even be fast enough if you have log square and because then now maybe you're doing a sliding window of every chunk. Okay, so I guess you could do it that way, which is to look at every 5. In this case, if we're searching for 4, then we look at every 5. Then we go, okay, well, now there exists a 5, so we have to set one chunk. I mean, it would work, but I think it's too slow with a segment tree. What else can I do if we have a segment tree? If I could do a segment tree about a binary search, then it would be fast enough. I don't know that I can. Well, yeah. I was gonna say maybe you could build that into the segment tree, but to get the stability. But I don't. But you still have to know where to modify, which I'm not sure about. Without the binary search. We're so close. The 10 to the 9 is really throwing me off. Okay, it was 10 to the 6 as an instant cell for me, I think. Like 20 minutes ago, but or 10 to the 5th or whatever it is. Maybe 10 to 6 is fine, but also I shouldn't have done it now because I think the real contest is like starting 13 minutes, which means the load time and there might be some other issues, but yeah, well, it's fine. The overlapping thing is just weird for me. Maybe there's a principle of the overlapping thing that I'm not. I mean, the other thing is that, I mean, I did a 2 overlapping here, right? But it can't even get worse. You can imagine, you know, another way of writing this is just that you have this 2 overlap, 3 overlaps for 3 prime. But you can actually always just like add another one, right? Like, so then now that just becomes 2, 6, I don't know, 30, I guess, 30, 15, 15, 5, 5, 5, 5, 5. And then now this is also a big overlap, right? So I have to figure out how do you do this without prime factorization? That goes up to 10 to the 9. So it's not even just like you could deconstruct into two, and you know, this can go as much as you want. And they also affect each other, right? You can't just like separate them out, I think. Because if you remove this 3 or this 5, I don't know. Like remove this 3, it doesn't help for this 5 and so forth, maybe, I don't know. They all interlinked together. We do know how to construct a bad case, at least, maybe. I mean, even with no max C, I don't know how to figure out the answer for this, right? The longest. Maybe that's the first part. How do we figure out with no max C, no changes, how do we figure out the longest thing? I mean, DP on the primes, but actually it's not that bad. That part is easy if the numbers doesn't go 10 to the 9, but it does go to 10 to the 9, so can I bring it forward? 2 and then 6. Maybe I can just look at all the previous numbers up to, because there are only 30 primes, right? So then maybe that means that we only have to look at 30 previous numbers. Maybe. Maybe that. I don't know if that makes sense, but let's see. Yeah, there can only be 30 primes, so maybe that is reasonable. So we don't have to generate the primes. We just have to generate what it is previously next to, right? Maybe that's right. Maybe that's the DP. Okay, what would that look like, Larry? All right, let's just write it without max C for a second. So then now we have first nums, right? Maybe something like that, right? Or streaks maybe. And then we have streaks of x is equal to 1, say. And then now we look at for k in streaks dot keys, something like that. Then now we go GCD, right? This HCF thing is weird because I just call it GCD. Are they trying to fool you or something? I don't know. Okay. And now streaks of G is equal to something like this. Plus 1 or streaks of K plus 1, right? Something like that. And then something like this, but it's not quite right because we don't want to, it should be new streaks. I think that's the thing. Okay, so then this is the new streaks. So let's just say we have the previous streaks and the new streaks. I think that's where we have to, because you have to be able to remove streaks that ended, right? So okay, yeah, okay, that's fine. So we have a new streak, and then for new streaks is equal to the previous streaks at G or K plus 1. Is that right? No, it's not quite right. In the sense that no, it's fine because it'll get extended in another one. Because my thing is that if that's like 10 and 20, then 10 is the GCD, but maybe you want to keep the streak on 2. But it only comes into play if there's a 2 in the future anyway, maybe. Something like this. Maybe that's right. And then streaks as you go to end streaks. And then maybe we just print it out every time for me to take a look to see if this is roughly right. Okay, so you have 3 and then 1 is, well, we have to remove 1. I think that's, I mean, maybe we don't, I don't know, it doesn't matter. 5 is 1, 10 is 2. Okay, that looks kind of what we want. I mean, we could remove 1 anyway, it's not a big deal. It's just that we don't care about it. So 2 at the 6 is going to be 2, 3, 8, 1. Why does 8 not intersect with 2? That's the thing that I want. Or 6. Streaks. 8 and 6. What is 8 and 6? Technically, I guess maybe this is max of 1 or streaks of x plus 1, which is fine. But why is this 8 and 6 is what? 3 and 4, so just 2. So okay, I guess this is just a streak of 2 at 2. I guess that's why. Okay. 2, 4, 6, 9. Okay, and then maybe we'll try the test case that I was trying to this thing. 2, 6, 30, 30, 15, 15. Let's just say 2. Whatever. I'm just trying to see how much work this has done. And then 2, so then the longest would be at 4. 3 would keep going at 4, 5, which is what we expect. And then 6 is, or 5 is going to go all the way to 9. The 1 we don't care about. We can throw away 1. Okay. Huh. Maybe this is the way that I think about it then, right? Because then now, binary search should be straightforward-ish, right? Maybe we have a... just got good, Larry. You could always score good. Okay, what does that look like? So given a target, we have count is equal to 0. So then, okay, you have this thing, right? Okay, so now that means that should we add a thing here, right? So for k in streaks.keys, if streaks of k is greater than target, then we just increment by 1, and then streaks is equal to collections.counter. Right, but we want to delete streaks of 1 if it exists. Just so that, because I think this gets triggered otherwise. And we just return count is less than equal to max c, right? And then now we can do a binary search. That was equal to 0. Does that ever make sense? No, I don't think it could ever be 0. And then what am I doing again? Oh, the longest thing. So that's just n, right? N. N plus 1. I always forget it was. No, it's inclusive, Larry. Come on. You're smarter than that. You've done this a billion times. Okay, so if this is good, then we want to try a smaller number. So right is equal to mid, else left is equal to plus 1, and we just return left. So we should see 1, 1, 2, or hopefully it just terminates. Why does it not terminate? Right is equal to mid. Am I really bad today? Maybe I am really bad today. I feel like I never really struggled with this before. I don't think this will time out, especially for these inputs anyway. So that means my binary search is wrong. Oh, why did I not do it by 2? Wow, Larry. Okay. All right. 1, 1, 1, 2 is right and 3 is from this thing, which I don't know if it's right. But all right, YOLO submit. No. I mean yes, but also maybe not yet. In that nums is equal to say 2 times. I don't know that this is the worst case though, because I mean this is definitely a bad case. Is it the worst case? Oh, it's because it depends on max C. It doesn't tell me the time though, does it? How do I get it to tell me the... yeah, sorry friends, my computer crashed in the middle of that. So annoying, right? Okay, very relatable. That kind of added, I don't know, at least 5 to 8 minutes to my time. I don't know exactly. I think this is the first time it actually happened, but we were about to submit too. Okay. I mean, I think I was not super happy with the time, but I think this is YOLO time, so let's just YOLO submit. Just was, it's very annoying. I mean, it may still time out, honestly, but I'm really kind of a little bit confused and lost just because of my computer crashing. Hopefully this is fast enough. Oh, well, wrong answer is not what I expect. Oh, 0. Oh. Okay. I mean, I guess I didn't expect 0 to be a possible input. That's why I put this at left. But let's go YOLO submit that. But oh, with no stable. Oh, I see. Huh. Okay. Maybe I just didn't. Yeah. We'll see if this is wrong. Oh, right or whatever. Ooh, time limit exceeded. Okay. Oh, 995 over 998. So we're very close. But and even this is like fast enough, so I feel like this is a case of of maybe if I convert it to another language that'll be fine, but Leetcode's a little like maybe I could be a little bit smarter about this, but it is what it is. So for example, if G is you go to 1, we continue. Maybe that's a little bit faster. I don't know. But now we're in like optimizing time situation 2.4 seconds, which is kind of like yucky, right? Okay, maybe this is much better. Oh, I should have converted these max. I didn't think I was kind of rushing this, so I didn't feel like I needed to. But again, this is like Leetcode being silly more than I need to, right? Oh, and then now we mess up because of 1. If G is equal to 1, we continue. Why is this 0? A subarray link point is stable if its element. Okay, so I guess there's this like weirdness thing. It does save me time, but I feel like this is also honestly, all right, let's just run this again with this, and then we'll see if that makes it a little bit faster in general. So okay, so the F max doesn't change it, but that too much for now. Don't there's so many issues due to things crashing and everything. I mean, it's the 0 case that is a little bit awkward, so maybe we should just do a 1 thing. How do we handle 1, right? Maybe something like if x is equal to 1, and we just continue maybe? I don't know. Because then now we just have a new thing, right? Does that give me 0? No, well I have to... no, I still output 1. Oh no, I didn't use this case. Did I use this case? Maybe I did. It's this one. Output 0, so that's right. It is kind of crappy that you don't get the thing about it anyway. I don't know if this is the right answer, but all right, let's YOLO submit. Maybe I'm just confused right now, but in general, to be frank, I don't know if this is the right way to handle that case. 996 out of 998. So I mean, again, this is like a way Leetcode like, how can I tell whether I'm timeouting or not, kind of thing, right? And it's just Leetcode being bad. So let's just convert to Java. I don't know why this is taking so long, but yeah, maybe that's fine. All right, let's see if it is better in Java because Leetcode sucks. I blame on Leetcode. Like maybe it is Java 18 only. Is there no way to do Java math GCD? Is that not a thing? I always forget. It's been a while. All right, so there isn't. Okay, fine. Where is it? 937. Okay. What's the answer? 112. That looks right, except for 8. I think. Oh no, that's the timeout one. YOLO submit. I should have checked the time, but that's fine. Maybe it's still a little bit slow. I mean, so I got it like pretty early, but Leetcode, it being Leetcode, it is what it is. Well, and the computer crashing, that obviously was not great. I have to check on my computer after recording, but yeah, what is my time? We have 27 minutes left, but I crashed for like 10 minutes or so, so I don't know, maybe something like that. And all four wrong answers is due to the optimization I had to make because Python isn't fast enough. Can I do it faster in Python? I guess maybe that'll be my upsell for now. Like maybe we don't use counter, maybe we use okay, so just I lost my test cases already. All right, I mean this is upsolving anyway, but if X is in streaks, I mean it's always going to be this. Okay, so then maybe we just write it out. So if something like that. Maybe I could even just write it in line, but maybe that's in it. I think honestly maybe this could have been a little bit cleaner. I don't know that this is quite whatever about it. Does this even work? This looks like it works. YOLO submit. Again, maybe too slow, but that's fine. I mean, we already finished, right? So, but it is. So I guess using that instead of counter would have saved me enough time to get it time in. But I mean, I was just mostly lazy. But actually, maybe not even needed. Yeah. Because I think even if this is, maybe I'm wrong. Let's see. Because I think. I see. I think there is something that I was doing a little bit awkward, which is that I was creating keys as I was doing it. So if I didn't have this, so maybe I could, maybe if I still had this, it had fewer things. But still, it's just such a minor thing to have to, you know. Let's see. Because I think this actually maybe creates additional keys that we throw away. So maybe that does it too many times, and not just the map and counter overhead. Counter does have overhead for sure though, but it is definitely yeah, okay. So maybe that, so maybe it is a counter. It is what it is. All right. I mean, yeah, that is all I have for this one though. Let me know what you think. Computer crashed. Silly. Thanks for watching. Stay good, stay healthy, to get good mental health. Oh, let me give a quick post-mortem or retro. I like to. I think Q1, Q2, and Q3 were pretty straightforward. I did them all 5 minutes. I mean, they're annoying maybe, but I don't think there was anything that tricky. I didn't get any wrong answers. The biggest thing is Q4, which the num sub I equals 10 or less than 10 equals to 9 thing definitely threw me off a bit. I definitely had the binary search way, like I knew it was binary search a little bit earlier on. I had this idea at some point. I was just like, maybe we don't need the entire primes. If you did it in entire primes, it would have looked very similar, but I thought maybe we can just, I don't know, this is an idea that I borrow from Alex from time to time. At least he's the first to kind of, for me anyway, to kind of like showcase the power of using kind of lookup tables in bottom-up dynamic programming in this way, in which the universe is just not super big, right? And the key thing here is the observation that if there are only dirty primes, then districts would have at most dirty numbers. I was thinking it's a little bit similar to the I forget what they call it. There's some like funky names that kids call it these days. I don't know, but it's similar to the idea of like if you go back X elements, like with bitwise AND or something like that, there can only be dirty distinct cases or something, right? It's the same with here. If the current number has at most dirty primes, which has to be less than that. I meant dirty primes because it's 10 to the 9 is 2 to the dirty, so it has dirty primes. But yeah, right. As a result, yeah, and it's kind of funny that as I was about to click on submit, my computer crashed. So I have to do some maintenance before I record the explanations. But it is what it is. But yeah, that is all I have for this one, though. Yeah, I mean, maybe I didn't talk about the full explanation, but the full explanation will be in the video, in the explanation video. So yeah, that's all I have for this one. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.